In this lecture, we will discuss some theory portion of the friction chapter, like the angle of friction, angle of repose, the relation between angle of friction to the coefficient of friction, minimum and the maximum value of the contact force, and condition for the motion of a block placed on a horizontal rough surface. What is the minimum value of the force which must be applied on a body placed on a horizontal rough surface to start the motion? First, let us discuss the angle of friction. Angle of friction is basically the angle made by the net contact force with the normal direction. When you try to move a body placed on a horizontal rough surface, obviously you will apply some external force. After applying the external force, there a resistive force comes into play between the contact surfaces, that is known as the frictional force. In the limiting situation, when body is just about to move, frictional force developed is maximum, that is called limiting frictional force. Total contact force is nothing but the resultant of the normal reaction and the limiting frictional force. Limiting frictional force and normal reaction, these two are the part of the net contact force. Net contact force is making an angle with the normal direction. That angle lambda is shown here is basically the angle of the friction. Just we discussed that the contact force have two parts, normal reaction and frictional force. It is not essential that every time frictional force will be the part of the contact. No. When simply body is placed on the surface, it is not try to move, then the contact force is equal to the normal reaction. So we can say the minimum value of the contact force is nothing but the normal reaction. But when you are just to try to move the body in the limiting situation, then the maximum value of the contact force is normal reaction as well as the frictional force. So maximum value of the contact force comes equal to normal reaction multiplied by root of 1 plus mu square. As well as see here, angle of friction is related with the coefficient of friction. The part of the contact force that is in vertical direction, the normal reaction n equals r cos lambda, and the horizontal component of the contact force, that is the r sin lambda, is nothing but the limiting value of the frictional force. So Fl equals r sin lambda and n equals r cos lambda. R is the total contact force, n is the normal reaction, Fl is the limiting frictional force. If you divide these two, you will get tan lambda. Tan lambda equals frictional force in limiting state upon normal reaction. That is a constant for the surface known as the limiting value of the coefficient of friction. So we can say tan lambda equals mu L, or lambda equals tan inverse mu L. In another way, we can say angle of friction is basically the tan inverse of the coefficient of friction. If you know the value of the coefficient of friction, then easily you can evaluate value of the angle of friction. Now see the angle of repose. Angle of repose is defined on a inclined rough surface. Let's see, there is a body placed on a inclined rough surface. The body have the mass small m. If you raise the angle made by the plane with the horizontal direction, a stage will come, then body will start slipping down. You can see the weight of the body mg have the two components, vertical to the plane mg cos theta, along the plane down, that is the mg sin theta. Component mg sin theta is responsible for the motion of this block. Due to the friction, a frictional force comes into play in opposite direction, that is the mu into n. When mg sin theta is sufficient to cancel the limiting value of the frictional force, then body start moving down. So angle of repose is defined basically angle made by the inclined rough surface with the horizontal direction at which body placed on it starts slipping down. Similarly, angle of repose is also related with the coefficient of friction, that is tan theta equals mu. The symbol of the angle of friction is lambda and angle of repose is theta. Both are similar to each other. Angle of friction is defined on the horizontal rough surface. Angle of repose is defined on the inclined rough surface. Now we will discuss about the minimum force applied on a body placed on a horizontal rough surface to start the motion. Minimum value of the force applied on a body is mu L mg upon root of 1 plus mu L square. The derivation of this formula is shown in the figure. You can see.